Today's notes are on solving linear equations and rewriting equations and formulas. To start, we have two vocabulary terms that we need to look at. The first term is a verbal model. A verbal model is an expression that uses words to represent a real-life situation. An algebraic model is a mathematical statement formed from the verbal model by substituting in symbols, variables, and numbers to make an equation. Let's look at example number 1. It says two airports, one in California and one in New York, are 3,000 miles apart. A plane leaving California is traveling to New York at 200 miles per hour. Another plane leaving New York is traveling to California at 250 miles per hour. After how long will the two planes meet each other? Well, we can start by underlining or highlighting any important pieces of information, such as the speed and how far apart they were. We can then write our verbal model. We're trying to figure out how long will it take the two planes to meet each other. To find this, we're going to use the distance formula from our notes from yesterday. So we have the total distance is equal to rate times time and then we're going to add that to another formula for distance to represent the two planes. So we'll say this first one is the plane from Cali. And the second plane is going to be the plane from New York. Next, we need to create some labels, starting with the information that we know. We know that the total distance is equal to 3,000 miles. We know that the rate of the plane traveling from California is 200 miles per hour. But we don't know the time. So we're going to represent that with the variable t. I also need to look at the rate of the plane coming from New York, which was 250 miles per hour. And the New York time, which again is unknown, and again will be represented with the variable t. From this, we now want to plug in our values to form our algebraic model. So I have my total distance is equal to the rate from California times the time from California plus the rate from New York times the time from New York. Now I have an algebraic model that I can solve. I can start by combining like terms on the right side of the equation to get 450t. I'm then going to divide both sides by 450 in order to get t by itself. This gives me an answer of 6 2/3. So we want to make sure that we then go ahead and answer the question, how long will the two planes meet each other? And the answer would be after 6 2/3 hours. Okay. When you finish example 1, please scroll down and look at example 2. Example 2 says, in a football game, the quarterback is 15 yards away from making a first down and is running at 264 yards per minute. After 0.03 of a minute, a linebacker who is 15 yards on the opposite side of the first down marker begins running directly towards the quarterback at 440 yards per minute. Will the linebacker be able to tackle the quarterback before he gets his first down? We're going to be setting up two different equations here, one for the quarterback and one for the linebacker. For both equations, we are once again going to use the distance formula. For the quarterback, we were told that he was 15 yards away from making a first down, and he was running at a speed of 264 yards per minute. We don't yet know the distance, so we're going to replace that with a variable t. Going through and solving for t, I can divide both sides of the equation by 264. We will find that t is equal to 0.0568. I'm now going to go through and do the same thing for the linebacker. We also know that the linebacker traveled 15 yards, this time running at a rate of 440 yards per minute. We still don't know the time, so we're going to place it with the variable t. I then need to divide both sides by 440 in order to get t by itself. That leaves us with a value of 0.0341. The other piece of information that we need to take into account is that the linebacker started 0.03 of a minute after. So we need to take its time and add 0.03, which really means that the linebacker's time to the first down was 0.0641. These two times tell us how long it took them to run to the first down line. Then we want to make sure we go back and answer the question. It asks us, will the linebacker be able to tackle the quarterback before he gets his first down? Well, we saw that it took the linebacker 0.0641 seconds to get to the first down mark, but it only took the quarterback 0.0568 seconds. Therefore, the linebacker will not be able to tackle the quarterback. For all these problems, you want to make sure that you answer the question in a complete sentence. Please flip it over and look at the next side. Problem number 3 says two sisters who live 500 miles apart Decide to meet at the halfway point for a visit. Joanne leaves at 11 and travels at 50 miles per hour. At noon, Sue leaves traveling 60 miles per hour. Who will reach the halfway point first, and how long will she have to wait for her sister? So we're going to set up two formulas, one for Joanne and one for Sue. And we are once again going to be using the distance formula. For Joanne, we know that if they're meeting at the halfway point and they live 500 miles apart, that they're traveling a total distance of 250 miles. Joanne also told us that she traveled at 50 miles per hour. We don't know the time it takes, so we're going to leave that as a variable t. If I divide both sides by 50, I can find that t is equal to 5 hours. Since she left at 11 o'clock, Joanne will arrive at 4. Sue is also traveling a distance of 250 miles, but she's traveling 60 miles per hour for again an unknown length of time. If we divide both sides by 60 to get t by itself, we find that t is equal to 4.17, which is 4 1/6 hours. That means that Sue will arrive at 4:10 because she left at noon. So we want to know who will reach the halfway point first. That would be Joanne. It also asks us how long will she have to wait for her sister, and that's going to be by 10 minutes. We knew that 1/6 of an hour was 10 minutes, because if you think of an hour being 60 minutes, 60 divided by 6 is 10. That adds the 10 additional minutes to our time. Please try example 5 and example 6 on your own tonight. We will go through 4, 5, and 6 tomorrow. For problem number 5, you are going to be using the equation for perimeter. And for problem number 6, you're going to be using the equation for volume. So read through the problems, decide which pieces of information they give you. You should have at least one variable that you need to solve for still.